Hi everyone, welcome to my channel. I hope you're doing well. Today we are going to begin a very interesting topic in computer science, data structures. If you are learning programming, you might already know how to write code, but understanding how data is stored, organized and used is the real secret behind fast and efficient programs. Now, before we go deep into coding or examples, let's take a moment to understand why data structures are so important. Imagine you have a hundred of pieces of informations, numbers, names or codes. How do you keep them in your program so that you can easily find and or remove them? If you just keep everything randomly, your program will become slow and confusing. But with proper data structure, you can your program neat, organized and very fast. You can think of data structures as the building block of every software system, whether it's a simple calculator, a mobile app, a website, or even an system. All of them use data structure insert. For example, when you scroll through your phone contact, that the data structures. When you browse a playlist of songs, that also data structures. Even your browse back button, forward button work using a stack. A stack follows the rule called LIFO, last in first out. Just imagine the stack of pairs. You add one top and you remove from the top two. In this video, I am going to show you one special type of stack called the list stack. It's built using a linked list. You will see how it works and how to code into Java. So stay with me till the end and you understand this stack clearly. Okay, let's get started. What is a stack? A stack is a simple way to store data. It follows one main rule, last in first out. It's called LIFO. That is a real life stack example. Paper stack, back button, undo function. Now we talk about what is a list stack. Normally, we can build a stack using fixed size array, but in a list stack, we use linked list insert. This is the better because our stack can grow and shrink easily. We never have worry about running out of the space. How to work it? Our list stack uses a special variable called top. The top pointer always point to the elements that is currently on the very top of the stack. The push method. Push added the new element to the stack. We create the new node, point its next link to all top, and then make new node the new top. The new element always goes on the top. Now the pop method. Pop removes the top element. We first check if the stack is empty. If not, we take the value from the top node, move the top pointer down to next node, and return the value. The peek method. Peek is simple. It shows the top element's value without removing it. Okay everyone, now let's look at the Java code for our this stack. We are going to through this code step by step so you can understand it very clearly. First, we have a class called node. Each node stores two things, the data and a reference to the next node. In simple word, a node is like one box that hold a number and point to the next box. The line in data stores the value and node next connect to the next node. Then we have a constructor node in data. It creates a new node each time we push a value. Next, we have the this is the class. Here we keep only one variable, not top. This variable always point to the top element in the stack. When the stack is empty, top equal null. Now let's look at the push method. The push method added new element on top of the stack. First, we create a new node equal new node data. Then we connect this new node to the all top. New node next equal top. Finally, we make the new node the new top. Top equal new node. So each time we push, the new element goes to top. The pop method removes the top element. First we check if the stack is empty. If top equal null, print stack is empty. Otherwise, we take the top element value. In value equal top data. Then move top to the next node. Top equal top next. This means we remove the all top. Peak shows what in the top without removing it. If the stack is empty, print stack is empty. Otherwise, return top data is empty. The method returns true if the stack has no element. It simply checks if stack top equal null. Now let's move to the main method. We create an object list stack equal new list stack. Then we push 10, 20 and 30. Now the top is 30. The stack looks like this: 32, 22, 10. When we pop, 30 is removed. Now 20 becomes the new node. Finally, when we peek again, it shows 20. So that's how the list stack works. Using the last in first out rule, we learn how push, pop and peek work step by step. Now example time. Let's see in action. I will push 10 and 20 then 30. When we pop once, the 30 is removed. Now 20 become a new top element. This proves the last in first out rule. That is advantages of list stack. Dynamic size, simple logic, efficient operation, practical uses. Alright everyone, we have now reached end of our video about the list stack in Java. Let's take a few minutes to summarize what we learned today. We started by learning what a stack is. A stack follows the LIFO principle, last in, first out. That means the last item we added is the first one to come out. Then we created a node class to store data and the next node references. After that, we made the list stack class which keeps track of the top of the stack. Then we learn how the push, pop, peek and empty method work. The push method added the new node on top. The pop method removes the top node. The peek method shows the top node without removing it. And the empty method check whether the stack is empty or not. We also look at how to run the program and see the output. When we push 10, 20, 30, the stack look like 30, 20, 10. When we pop, 30 get removed and 20 become the new top. So everything works step by step, very clearly and logically. This example helps us understand how a stack can be made using a linked list. It's a simple but powerful concept in the data structure because stacks are used in real programs like undo features, back button, and memory management. So, if you understand this example, it means you will learn something very important in programming. Don't worry if you didn't get everything right now. Just practice again and write the code yourself. The more you practice, the more you understand. Now, before we end the video, let's review the key point. A stack is a life structure. We use node to connect data, push add data to top, pop removes from top, peek shows the top value, empty checks if empty. And that it, we have completed our full explanation of the list stack. I hope this video helped you understand how stack work. If you enjoy this lesson, please like this video and subscribe for more. In the next video, we will learn another data structure. So stay tuned, keep learning and never stop coding. Thank you so much for watching. See you in the next video. Bye bye.